if I just put this money into this account and let it sit for a year and it only got interest every once a year, this is what it would look like to calculate the money after 1 year. $6,200 times 1.084. Okay, that would be it. That would be how much money you got after 1 year if it sat in their entire year. And at the very end of the year, the last second on December 31st, they then calculate how much money they owe you, and then you can take that much money. Okay. We talked about how that's not ideal. What if I want to take out my money at some other time? Okay. So I want to take it out at any given month. Right? So that's what we're going to look at. What about if I was able to take out the money at any given month? Is that a question, Kyler?
Yeah, I was gonna ask about that.
About what?
About the 18 months thing. Wouldn't you try to put it to 18 power?
No, because this is how much, like if I multiply this by 1.084, so $6,200 times 1.084, that's $6,720.80. That's how much money I would have at the end of 1 year if I got all of the 8.4% interest all at once. They just calculate it once a year. They calculate it essentially at the very end of the year, and there it is. That's how much money you have at the end of that year.
So that'd be 12 months.
That would be 12 months.
Okay.
But not done monthly. It's just done at the end of the year, once a year, where they give you all 8.4% all at once. All
so
at
12 months is a year. That's what I'm getting at. So
Yes.
1 year times it.
No, Tyler, you've got to chill out for a second so I can get there, okay? I'm trying to explain something, you're trying to jump ahead, and you're going to confuse yourself. So listen to all the words I'm saying, and stop trying to jump ahead. This would be, if you only gave, or the bank only gave you 8.4% all at once, all at the end of the year. But if we wanted to be able to take the money out at any given month, I want to take it at the end, not the end of the year, but the end of January, the end of February, or so on, then they need to be able to calculate how much money you have at the end of each month, right? So now I'm not going to get 8.4% all at once now. I'm going to get some of that 8.4%, right?
That 0.00.
How much of that 8.4% am I going to get?
When you just do 18 divided by 0.084.
No. In 1 year, in this entire year, I would get 8.4% over the entire year. Now, we're not going to get 8.4% all at once. We're going to get it in little pieces every month. Every month. So, that.
1.42.
Okay, 8.4% really.
Divided by 12.
You do 12 divided by 8.4.
0.084, right? That's what 8.4% is as a decimal. We're going to get the 8.4%. I would multiply 6,200.084. But we're going to get just a little piece of it, right?
Right.
Just a little piece of that each month, so that if we were to add that all up, we'd get a total of 8.4%.
No.
Don't tell him.
Because then you have time to give 12.
Okay. So we're going to split this up into like one little piece of it each month. How will I figure out how much of that percentage I get in this 1 month?
Divided by 12.
Divide that by 12. So 0.084 divided by 12, that's how much is going to be there. 0.084 there. Or sorry, 0.084 divided by 12, right? That's how much you're going to earn each month, so on and so on and so on. Every month you're going to get 1/12 of the 8.4%, which makes sense because there's 12 months in a year. We're going to get So instead of getting 8.4% at the end of the year, we're going to get 100% plus this little extra piece, this 0.084 divided by 12. If I were to multiply 6,200 by this number, that's going to give me, I'll get into the calculator, 6,200 times 1 plus 0.084 divided by 12 equals, that amount is $6,243.40. Now, when will you have got that much money?
At
At the end of the year. Oh, 18 months.
The end of 1 month. Let's look at what we're looking at. Okay, if I multiply 6,200 by 1, that'll be the 6,200 I started with. Okay, and I'm going to multiply it by this very small number, right, and add it on. So we're going to get 6,200 plus this little bit. Okay, let's think about this little bit for a second. This 0.084, where does that come from?
It comes from the percentage that you need each annual.
Every year I should get a total of 8.4% more on top of the money that I invested at the beginning. Well, we're doing it every month. We're dividing this annual percentage by 12 because we're letting it recalculate the compound every month. So we get this little piece added on to the original amount, and this would be in 1 month. So that would be the amount after 1 month, $6,243.40. That's how much we have after 1 month.
6,242,43.
If I take 6,200 times 1 plus 0.084 over 12,
That's the same thing.
what is this number equal to? Yeah, what number is all of this equal to?
1.
This whole thing right here. Well, it's equal to how much I have at the end of the first month, which is
6,242, I think.
right, that amount we just did. That's how much I have, 6,243.40. That's how much I have after 1 month. Right? Okay, so that is my new amount. So I invested $6,200. And it sat there and sat there and sat there until the end of the month, essentially the beginning of the next month, right? It
Mhm.
grew just a little bit.
$43, $43.43.4.
I think it grew by, no, you're right, yeah, 6,243, so it grew by $43.40. Because now we're at 6,243 and 20 cents.
No, it's 4.
What?
It's
Yeah,
40.
yes, it was, I just said it was 40 cents. Okay, well that's how much you have at the end of the first month, or really, I guess, kind of, if you collected any time in February, it's going to be that much, because they're not recalculating it every day or every hour continuously, it's just every month. If I wait until the end of the month, end of February, I get some more money. How are they going to calculate that?
They're gonna multiply that by 0.084.
No.
Under the next month?
Into the next month, for this next amount of money, the next month.
So that's for
Yeah, just do the same thing again, right? The same thing again. Right here, how do we get this? Well, how do we get this amount? We multiplied 6,200 times 1 point, well, I guess 1 plus, because we don't want to round, 1 plus 0.084 over 12.
Well, that right there now be, what do you think, instead of 6,200, you put 6,243.4?
That's what this new amount is going to be, right? We could take
Yeah.
6,243 and 40 cents and multiply it by the same thing. It's going to get that little extra percentage, 1/12 of 8.4%. again. And we take that new number, we do it again, that new number, we do it again. But this amount right here is just 6,200 times 1 plus 0.084 over 12. So I'm taking 6,200, multiplying it by this parentheses, the exact same parentheses the second time, right? And another time, and another time, and another time for however many months we want to calculate for. So, instead of getting that new amount every month, and then multiplying it by 1 plus 0.084 divided by 12, and getting that new amount and multiplying it by that again and again and again, we could just multiply it by this many times. How many times would we raise it?
18.
Okay, for 18 months, we'd raise it to the 18th power.
Yep.
Okay, that would give us the total amount after 18 months. But if we want a formula so that we can calculate for any amount of time.
Wait, right, if you're writing a function, wouldn't the function just be 6,200 1 plus 0.084 divided by 4? Wouldn't that just be that for the function?
This isn't much of a function because this, I can plug all this into my calculator. There's nothing that I don't know. I just plug it in and it tells me the amount. The same amount that we talked about here, $6,248,
Well, then,
$43.
Oh, alright, so then you could do 6,200 times by 1.007 and times it by 18.
No, not times it by 18, but raise it to the 18th power,
Yeah.
which we've already done. So what we're trying to write now is a function or a formula for any amount of time. Okay? If I leave the money in there for a long time, does 6,200 change? Or does that stay the same?
Let's say the same.
Because 6,200 is what?
The beginning.
The beginning. Whatever I did at the beginning, it's always however much I invested at the beginning. Would this change?
Yeah.
1 plus 0.084 divided by
The
12?
The one would stay the same.
One would stay the same. Would this change?
Yes.
In what way would this change?
Because you're going up. You're increasing. No, because it's annually, so it'll stay there.
No, this is by month.
I meant, no, the 0.84.
Yes, okay, so that's how much you should get every year, divided into 12 pieces for once a month.
Yeah, the 12 could change, because then you could do 2 years, which is 24 months.
But we still are doing it month by month by month by month by month.
Oh, good point.
Every month is going to have this much extra added on to it.
So yeah.
1/12 of 8.4%. That would stay the same.
Is that right? Yeah.
The only thing that changes is how many times do I multiply this? Multiplied by this 1 point,
By 1, by 2,
whatever that
by
is.
3, by 4. Can you do that?
Multiply it by 3,
I mean, to the power of 3.
power of 3. What would that mean if I put it to the third power?
For 3 months.
3 months, but I want it to be for any amount of time, right? I want you to be able to tell me then how long it's in there, and then I can tell you how much money there is by using this formula. You already know really what it pretty much should look like. You just need the number of months, right? You raise it to that power.
18.
We need it to be adaptable for any amount of time. If I put 18, it's just calculating for 18 months.
So you need a function that makes it.
Well, for the 12, put a t for time.
Here?
Yeah.
Oh, yeah, I get
go ahead
that.
and put a and then like an exponent, you put t for time, and then the rate.
We don't want to do that. Okay, so let's take this away for just a second. This part right here, if I multiply a number by 1 plus 0.084 divided by 12, okay, whatever that number is, after I multiply it by this, the new number will be whatever that previous amount was plus this much extra, right? This much percent extra. Let's look at what that decimal is. 0.084 divided by 12. That works out nicely. It's exactly 0.007.
Told you.
Nobody argued with you.
Yeah, but you didn't agree with me.
Didn't do anything.
You didn't agree.
1.007. So this, whatever we multiply by, that number is going to be 0.7% bigger than it used to be. If I multiply by 1.007, I'm going to get this new number that's slightly bigger. It's 0.7% bigger than it used to be. So
Times it by 6,200.
if I multiply by 6,200, that will be 6,243 and 40 cents. That's after 1 month. So if I want to continue growing this money month after month after month, I would just need to keep repeatedly multiplying by this 1.007. If I added up 0.007 12 times, that would come up to 0.084, 8.4%. If I multiply by this number 12 different times, that would be the equivalent of growing my money by 0.7% for 1 month, 2 months, 3 months, 4 months, 5 months, 6 months, 12 months. Right? But that's not a formula. That's not a function. I need to write a function that any amount of time essentially can be put here in the exponent. Okay? So, Aiden, what do you say? Okay, to the t power. Now what does t represent?
Time.
More specifically months. It would have to be months, right?
Yeah.
So I can say that's the formula as long as you understand that you have to tell me the number of months. Okay? But we usually don't say that. We usually put things into bank accounts for years and years and years, many years. 30 or 40 years. Okay? Or retirement accounts. So how do I make it so that I can measure t in months, or sorry, in years, but the formula will still work because I need this power to be the number of months.
But it's 12.
Yeah?
Times it by
Which variable? Okay. Now what does that n represent?
Years and
the amount
What does t represent? T represents the months and years. What does n represent? Okay.
The annual rate? Oh, I don't remember.
All right. This is why I'm going through all of this explanation, because you guys don't know what that means. We could easily understand what it means if we all just relax, put on the brakes, allow all of the explanation to happen. And I would have to explain a lot less if people weren't trying to jump ahead and confusing those people who are trying to pay attention.
I'm trying to pay attention.
No, you're trying to roll over me.
I was trying to pay attention.
Trying to
and
throw
learn.
the answer up there before it's been explained. And you were not listening very well today.
I was just, okay, I'm just gonna say something.
Go ahead.
Okay. I was trying to learn it, but I was just jumping ahead because I thought I knew. So then I was just giving answers out there because, I mean, isn't that
Tell me
okay?
if giving answers is a good example of listening, or is it a good example of jumping to the end and the answer?
No, probably last one you said.
Right. We're listening, we're growing in understanding. If you just want the answer, then don't know I don't know what your plan is for the future if you just, it's like, oh, I'll just write down the answer. But unless I'm there whispering over your shoulder the answer, or you have the answers written down, you have a computer on you that tells you the answers for everything, you're gonna need some understanding to build out the answer. Okay? Okay. So, can I take it to the 18th power? Sure. I can take it to the 18th power. It's not what we're looking for right now, but I could take it to the 18th power. But if I take it to the 18th power, and this is going to help us understand something, if I take it to the 18th power, well, that's not a formula. That's just like, that's a number to a number. Like, that's ready
That's
just
the
to be
answer.
calculated. That's a specific answer for a specific time, right?
Then what? So then you could.
So here's my question, which invites an answer, but also tests to see if you're listening. If I take it to the 18th power, when I get that number, because I can just multiply that all together and raise that to that exponent, it's a number waiting to be calculated. When I calculate that number, what does it mean to me? Kyle? If I take it to the 18th power, what will the resulting number mean to me?
It means that's how much you have after 18 months.
Yes, it's how much I have after 18 months. Okay? So what I need here in the exponent is the number that represents what?
The 18 months.
Well, I don't want only ever 18 months.
Oh, the number that represents the time that's gone by.
The time that's gone by. I need this exponent to be the time that's gone by measured in what?
Years, months.
Yes, I need it to be in months. So if I know the months, like this, like 18 months, I just plug in 18. But what I was saying was, we don't usually say, oh, and I invested my money and I left it in there for 314 months. You don't usually say that. You say, I left it in there for 12 years, 20 years, 30 years, right?
Yeah.
1.5 years.
So, Kyle?
So the 12 right there, that's because there's 12 months in a year, right?
Yes, we're taking that 8.4%, we are splitting up into 12 pieces
Okay.
so that we can calculate a smaller part of it once a month. Yeah.
Okay.
That's why that's there. Which is useful to us now because
You're solving.
if I need the exponent to be the number of months, okay? Let's just imagine this, just forget this for a second. I need to know how many months have gone by, okay? Vaguely remember, that's what we said the exponent needs to be, right? We need the exponent to be the number of months. If I tell you that 3 years have gone by, can you tell me how many months that is?
36.
36 months. How did you do that?
12 times 3.
12 times 3. What if I tell you a new year? What are you going to do with that year?
12 times something.
12 times something. You just told me what the exponent needs to be then.
12.
12, because in that formula that you're looking at and trying to use and plug numbers into, n represents the number of times per year the new total is calculated, or what we call compounded. How often is it compounded? In this case, 12 times a year, monthly. It's compounded 12 times a year. Right? We divide the entire annual percentage by 12 to get that little monthly piece of the percentage that we get once a month. But since we're doing it by month, we need to raise it to the power of the number of months. So we need to take the number of years and multiply it by the number of months in a year, the number of times in a year that we recalculate the money. Okay. So we're going to do this again. Hopefully we can listen to the explanation. It takes much longer when we try to jump to the end because I don't want to just say, no, you're wrong, because they're not wrong, and I don't like telling people they're wrong when they're not wrong. But I do have to address it, it just takes longer, so let's just listen to the questions that I'm asking, answer those, and don't try and jump ahead. Okay? Kyle, let's put that phone away unless we'd like to have it go.
I'm calculating.
Let's put it away, and I have calculators here. Number 20. Okay, so this is just kind of a mental exercise. Not a lot of things to calculate here, just something to discuss. So the number of sick people triples every week. Okay, let's try and, let's set up an example. Let's say that there's 9 people who are sick at the beginning, okay, a week passes by, now 300, or sorry, not 300, 3 times the number of people are now sick. So how do I calculate the number of people who are sick at the end of the first week going into the second week?
Times 3.
Times 3,
To the-
multiply by 3.
No, times 3, not to the third power. That's
Okay, yeah.
Okay, just 9 times 3, because it triples, so 27 people now are sick.
Mm-hmm.
Okay, 27 people now are sick, and a week goes by, and now the number triples again. So how do we calculate how many people are sick now?
Times 3.
27 times 3, right?
Yep.
That is 27, so I can just multiply it by 3. And it triples again, and it triples again, right? So we have like our initial amount of 9 times 3 to the, let's say, W, the number of weeks. Okay. However many weeks go by, I can just multiply it by 3 that many times, 3 to the W power. But the question is asking, what's the growth rate? How much is it growing by each week? Is it growing by 300%?
No.
Wouldn't it grow by 3%?
Not by 3%,
30.
like, it's asking how many more percent is there
30.
the next week as compared to the previous week?
3 more?
No.
3, it's a tricky thing, it was like 3 times as much, but how much got added on? How much percentage got added on?
30%.
200%.
Yes, we had 100%.
200.
Right?
Oh, okay, I get that.
In
So you're
the
adding
beginning, we
another
had 100% of the people,
Oh.
but then we gained 200 more percent.
Right.
100% of that is what we had to start with, like those people who were already sick. And then some more people got sick. 200% more people got sick.
And then 300.
There's, okay, so if I,
Or would it go up by 100% every?
200% is what is getting added on every week to the previous week's total.
Yeah.
Okay. Yes. So 9 times 3 is 27, which is 200% more than 9. Right? 9 of it is the original 9, and then on top of that, there's 18 more people, 200% of 9, that are added on.
Well, then how did you get the 27? Maybe I should look at my book.
Suppose.
During it, the number of sick people triples every week, but it doesn't say how many people are sick already.
That's true, but it wouldn't matter. I could throw I could throw 9 on there. I could throw 10 on there. I could put
3,356.
356. It won't matter. This new number will be always 3 times as much as this previous number, which is always 200% more than what we started with. It's always 100% plus 200 more percent. With this growth, some of that new number is what you had before. Not necessarily to start with, but what you had the previous time, right?
So
The previous cycle.
what you start with, alright, so say like you had 9, times it by 3. So 9's the starting, so that's 100%, and
Yes.
then you add in that 2 on.
Yeah.
Okay.
If if we use the formula, it would look like 9 times 1 plus, right? But this plus we had on, it's not even a decimal, it's like, it's so big, it's 2. Right. So 9 times 1, okay, that's the original 9.
Oh, plus, okay.
Plus 18, to get it on, that's what gives us our 300% total at the end of each week. Right? And it does not matter what this beginning number is. It could be any number. I'm still going to get the number plus 2 times the number is 3 times the number. Okay. 100% plus 200 more percent is the total up to 300%, tripling. Okay. So we would take that 300%, or that 3, number 3. We always have that 1 plus our growth rate. Okay. It's really just kind of reminding you of some vocabulary. This is called our growth rate. Because this 1 is not any growth, it's just exactly what we started with. This plus part is the growth. If this was a 0, there would be no growth. It would stay the same no matter how many times you multiply it by just one, because there's nothing added on. That's why it's called the growth rate. That's the rate at which it grows. Yeah. So it's really just a reminder of vocab. That's how much it grows by. Grows by twice as much every time.
That's pretty neat.
Yeah. Number 21. Unless I overlooked a hand raise.
Nope,
No.
21, right?
Okay, 21. A lot of information here. $9,000 invested. Savings account that earns 3.6% annual interest. Compounded monthly. Okay, that word compounded just means like how often they recalculate. Okay. Or how often you're allowed to take your money out. Compounded monthly. Okay, you also save $40 a month at home in a safe. Does that money grow?
Yes.
Can you move back to your seat, please? Does that money in the safe at your house grow?
Yes.
Yes.
How does it grow? Where does the growth come from in the house? Where did you put money in a safe? You lock it. How does it grow?
100% each month,
It grows by 100%.
because $40. Oh, but it doesn't say how much
Oh,
was in it.
okay. Excuse me. It grows every time I add to it,
Oh,
but it doesn't grow because like if I put it in there, it only grows if I put money in there,
right.
right? At the bank, I put money in there, and it just grows because the bank essentially pays me to use my money.
No, it says you also save $40 per month in the safe account.
So it grows, but it only grows because I'm putting more money in. At the bank, I don't have to do that. At the bank, I just put my money in there, and it just grows because the bank is growing it for me. Right? So the money at home grows every month because I put more money in. It grows by a fixed amount every month or week?
Annual.
Month.
Month, every month.
So then you.
It only grows because I add more to it. But at the bank grows based on how much there is. The more I have in there, the more I get. The more money I get.
So I get this, okay.
So part of it's at the bank, part of it is at home.
So then you could take, that $40 and times it by 12 for the 12 months.
So if I were to do this for 12 months, I would multiply 40 by 12, that's how much money I have at home. Right? Just a simple calculation, 40 times, doesn't have to be 12, right? It could just be 40 times what?
12 T.
T
For
is,
time.
T is measured in
Time as in months.
In months, not years. Months. Make a little note. Months.
Excuse the interruption. High school softball practice will begin tonight at 5:30 in the new gym. High school softball practice will begin tonight, 5:30 in the new gym. Thank you.
Okay, and what? This might be confusing. Here's some function notation. They're saying write a function C of t that's equal to essentially whatever formula tells us how much money we have from the bank plus the formula that tells us how much money we have at home. Those are the two formulas. We add the totals together and we have the total amount from bank and from home. $40 saved at home, write a function. So the formula that tells us how much we have, well, at home we already have that 40 times t, where t is measured in months.
So so it'd be 480 T. Because you're taking it.
Well, it's either 42 or 480 t.
Yeah, 480.
Which is it, 40t or 480?
480.
Why would we change it to 480t?
Because the full year.
Okay, so yours, are you measuring t in months then?
So times
This would suggest that after 1 month, I have $480 at home. Is that true?
Mhm.
After 1 month?
No.
No,
No.
you'd have $40 at home, plus the beginning amount.
Right, $40 at home after 1 month. At the end of each month I put in $40.
Yeah.
Okay, well, this is $480 after 1 month. But at 40 times 1 month, $40. Now, if I want to switch over to using T to measure years, well, then I would be saving $480 a year at home, and so I would put 480 T as long as T represents years and not months.
Safe, okay, so it represents the amount in your safe after T. So that's what it just said.
Oh, so it's telling us we have to measure T in years.
Yeah, array of functions, C.
Okay.
Yeah.
Then yeah, we would have to, if T is forced to be years, then we'd have to change this to how much money we save at home in the safe after 1 year. And that is $480 in 1 year. 480 times 2 years, that's what, $960 in 2 years. Okay, this is how much we earn in 1 year, 480 times T, the number of years. Now we have to work out the formula for the bank. And as it has been in the many examples we've done, $9,000. One plus. Can you close the door if you're going to be loud out there, please? So we're going to add on a small percentage each month,
So,
which will be 0.036
36.
divided into 12 months.
So it's pretty much, it's 9,000.
In 1 point.
Whatever that is, yeah,
0, 0, 0.
It has to be, we have to calculate this based on the number of years, which means we need to raise this to the 12 times T, because if years times 12 months, right? And this is based on a monthly growth. So this part is 9,000 times 9,000 times 1 plus 0.036 divided by 12. 12 T power. And for both of these, if I plug in the number of years, even if it's a fraction of a year, like 6 months, half a year, I can plug in 0.5. That would cut this amount in half. That is how much I would save after half a year, 6 months. The number of years, right? That's what I have to plug in for T. We cannot plug in 6 if it's been 6 months. 6 would be 6 years.
Right.
So it'd be
So
0.5 for the number of years if it was 6 months.
Yeah.
So we're supposed to calculate for the number of years? No?
No,
No,
and then,
I don't think so.
Then it says, what is CT
What does C of T represent?
all the amounts of the,
All of it. Bank and safe. Right?
that one was easy.
That one. If you turned your homework in, collect it back because I did not ask for it today. And